Okay. Let's go through LTF number 12 questions that you guys have. Any multiple choice or FRQs? It's a go-gurt. Number 7 and 5 and 9 and... Okay. Anybody have a question on number 1? Let's just start there. Yeah? Okay. Let's talk about number 1. P.S. Let's go before number 1. Because you might have skipped these ones before, but I think that this is probably one of the most important skills to practice. What came before number 1? Can you guys look at the pages before number 1? Practice for preliminary steps. Translate into calculus speak. When it says the area of a circle is increasing at a rate of 6 inches squared per minute, how did you translate? How should you translate? dAdt. Good. Why? Because this is time and this is area. The area increasing at a rate of. dAdt is 6. Good. How about number 2? Volume. Decreasing. Rate of 2. dVdt equals negative. Why negative? Decreasing at a rate of. The population of a city is growing at a rate of 3 people per day. Make up something. Volume is V, area is A, but make up something for population. It could be dPdt, it could be city, dCdt, I don't know. But dPdt, sure, why not? Is growing, positive or negative? 3, positive, good. Now translate into words. When you guys see these ones down below, let's say they give you not the words, but they give you the expression, or you see this. What do you think dCdt could be standing for? Yeah, the rate of change of circumference is... No. Look at the words up above. Look at the words up above. Increasing. Does that make sense? At a rate of 2 inches per second. How about number 2? The radius is increasing at a rate of 40 centimeters per second. How about number 3? The volume, now careful, is decreasing at a rate of? Good. Don't say negative. You already said decreasing. So the volume is decreasing at a rate of 28 feet cubed per minute. Why am I saying this? In an FRQ, when they ask for you to interpret the meaning of something that is a rate, they want you to say the word increasing or decreasing. How do you know it? Just look at the rates, the derivative sign. That's it. Does that make sense? And include the units. Now,
wait, so would it make sense to say it's increasing at a negative?
No. Yeah. Does that make sense? Cool. Okay, hold on. What's this page trying to make you practice? Differentiate with respect to t. Are you finding dAdr or dAdt? How do you do dAdt? Take ddt of both sides, right? What's the derivative of 1a? What's the derivative of the next side? 2 pi r. Don't stop believing. Okay, so how about number 2? 2a dAdt 2b dBdt equals. Good. How about number 3? Is equal to, you guys see them taking ddt of everything, right? And every time you implicit differentiation, if you're taking a derivative with respect to a variable other than, you need the u prime, which will be the dAdt, the drdt, the dA, the dB, the dCdt. So what's this guy? 2, not 2l. dL dt, good. Plus 2 dW dt, good. Ooh. Good. Now slow down. Do you see it? We have to do product rule. So second, d first. Bring down the 2. 2 pi r, but you took the derivative of this guy who has r's. I need dr dt. Good on. Plus, help us out, pi r squared times, good. Do you see it? Times derivative of that guy, dH dt. What were they banking on? That you would forget your product rule. What did I do? I grouped it into 2 pieces. That was just a constant, so I just joined them together. Is that okay? Yeah. Cool. How about the...
I just plugged in R first. Can you do that? Is that safe? Is that legal?
Not if R's changing. That's completely illegal. because r is not one value if your size is changing. R is needing to be variable. This is before, yeah, if you're paying attention, it was before the multiple choice. Number 5, how do you do that one? d/dt, good. What's on doing? H times 1/2 dB dt. Product rule. Good. So second H times the first dB dt plus first d second. Yeah. And you can just group the 1/2 in. Good. Now, what if I was to do something like this? What if I was to do, Tyler, here's an example where you could plug in. What if I had a ladder? Yay. What if I had a ladder that was slipping down a wall? And as it was slipping out, it was pushing out. We had that one homework a long time ago. Is A changing? Yes. Is B changing? Yes. Is C changing? No. Now I can plug in C. But I would have to keep A as a variable, B as a variable. And let's say they tell us the ladder is 13 feet long. Okay, I can plug in C, because that's unchanging as long as my ladder doesn't break, but that's not an ideal problem. That's a random thing that could happen. So keep A a variable, keep B a variable, C is constant. Now, what if I was to go take the derivative of this? 2A d/dt plus, keep going, equals 0. Good, equals 0. You would have to account for that when you take your derivative. And if you left this as a C, because you didn't think about plugging in, it'd be 2C times dc/dt, but what's the derivative of a constant? 0. So you'd have to think of, oh, the ladder's not changing. Oh, it's constant. Oh, derivative of a constant is 0. But it's a lot to think of if you wait to plug in until later. But only plug in something that, as you picture the movement, it remains unchanged. Does that make sense, Tyler? Okay, so now let's go to the multiple choice. Number 1, the radius of a circle is increasing at a constant rate of. Calculus speak. How do I put that? Radius increasing rate of. Good. Does that make sense? What is the rate of increase in the area? What am I finding? d/dt. Good. Such that C equals 60 pi. Some of you might need to put into a forever card, like maybe the pre-cal cards at the beginning, or maybe like in your when you see you think. You might need to put in C equals 2 pi r. Maybe you need to remember and put that in your forevers to be studying, maybe. Hopefully we all know area because we use it for discs and washers. What's area of a circle? Uh-oh. Whew, scared me. Now, why would I take a derivative of this guy? Yeah, I need d/dt and dr/dt, so it comes out of this one nice and easy. d/dt is equal to 2 pi r dr dt. Now, we have options. Number 1, we could say, we don't have r. We have to go find r. And we could plug 60 pi over here into C. We can be like, all right, let's go find r. Let's plug it in. Or we could say, hold on, who's 2 pi r? Oh, can't I just plug them in right there for the whole thing? That's cheating. But yeah, you could plug it in here and solve for pi. 60 pi, solve for r, 60 pi divided by 2 pi will be 30. R is 30, plug in 30, 60 pi. Oh yeah, duh. So then we go ahead and plug in. So I can plug in 60 pi times dr dt, 0.4. And I end up with my final answer of, that's 2/5, 1 and 12, and 24? Da, 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 da. Is that okay? Cool. Who has a question on number 3? Anybody?
Oh, that's just 24.
Ah, yeah. Yeah. Thank you. I did it too quickly. So the correct answer should have been C. Thank you. Dangerous. Okay, any questions on number 3? Okay, number 5? Yes. Bikes A and B are traveling on perpendicular roads. At the same time, bike A is leaving the intersection at a rate of, you guys okay if we use dA/dt for bike A? Is that okay? Yeah. Okay. So we know dA/dt for bike A is equal to 2 feet per second. And then bike B, we have dB dt is equal to 3 feet per second. And they say traveling on perpendicular roads, how fast is the distance between them? Leaving the intersection, so one's going one way, the other one's going the other way, so we can call this one like A, we can call this one like B. The distance between them, isn't that going to be a distance between them? Isn't the distance between them going to be a hypotenuse? So how fast is the distance between them changing? We could call that like d dt, or you could do a and b and c for Pythagorean theorem, and then you could do dc dt if you would like. After 5 seconds, such that t equals 5. Okay, what's the equation that relates a and b and d? Yeah. A squared plus b squared is equal to d squared. If you want to make it c, that's fine, I understand, but I just did d for distance. So then we have our 2a dA dt. However, if you guys got this far, it still got really tricky right about, yeah. Because, can I plug in for this guy? Yes. Can I plug in for this guy? Yes. Can I plug in for anything else? So how do we find A and how do we find B if all they give us is 5 seconds? Wait, 5 seconds. Distance, how far A is gone. Distance, how far B is gone. Distance can be found by rate times time, right, guys? So can't I say that A's distance is going to equal A's rate of 2 feet per second times how many seconds it's been traveling? Won't the second cancel? If you've been going 60 miles per hour for 3 hours, how far have you gone? Just more, right? If you've gone 3 hours, you're going 60 miles per hour. Haven't you gone 180 miles? That's what you're doing here. You're saying 2 feet per second. You've gone 5 seconds, so how many feet have you gone? 10. How fast is bike B going? 3 feet per second for 5 seconds. How far is bike B gone? 15 feet. So I can plug in 2 times 10 times my dA dt, which is 2 feet per second, and that's feet. Now I have my 2b, which is 15 feet, times 3 feet per second, equals, oh no, and I don't know d? Wait, I have a formula. Go back to your relationship. Can't I say that if A is 10 and B is 15, I can solve for d? Which will be 100 plus what, 225?
If 5 was the square root of 15.
Oh, when you pull out the 25. Got it, got it. So when you rationalize, sorry, they were simplifying. So then all we have to do is add these two together. I mean, this is multiple choice. You can't stick it to the man. You got to get an answer, right? So 2 and 2 is 4. 4 and 10 is 40. 40, and we have 30 and 3 is 90. 40 and 90 is 130, right?
Yeah.
So dt is 190 divided by 10 rad 13.
130.
130.
Oh, thank you. 40 and 90. I was too busy talking and not writing down what I had just done in my head. 130, thank you. The 10 will cancel out with the 0, so I have 13 over rad 13. Oh, it's not matching, but why not? Can't I rationalize? And maybe if I rationalize, I'll figure out this is actually not as hard as it looks. 13 can be rad 13, so 1 cancels out.
Yeah, but this is just so much work.
Yeah.
It's like, but you're not going to get this done. So this is one of those.
You can.
No, like.
In the 1.2 minutes, true. So if you're,
One of those,
thank you. So if you're gauging your time, and if you get to something like, you get down to here, and you're like, I don't have anything to plug in, I have to go find stuff. Maybe keep going. Or maybe you're like, but I actually know how to do it, so I'm going to get this point instead of wasting it somewhere else where I don't know how to get a point. It's up to you. There are two different strategies when taking multiple choice. One strategy is to keep an eye on your time, and if you're like, this one's taking too long, to put a star and be like, I hope I get back to it. If you skip a multiple choice problem, and if you've gotten some of the work done, my advice would be, if possible, to at least have on, because you guys have that big old, like you have tons of space, right? My advice would be to at least have like the 1 or 2 top answer choices. If you can narrow it down to 2 answer choices, pick one. Just have a star on it, so if you have time, you go back. But here's what I'm trying to avoid. I'm trying to avoid you getting down to the end. You have 30 seconds left, and you can't actually flip back to all your questions. You could have it narrowed down and have a 50-50 chance, but you just pick an A, B, C, D. All of a sudden, you have a 20% chance. So my advice would be, and so Tyler, it depends. Maybe like real quick, you see this one's long, I'll come back to it. However, if you're able to at least get partially to, which this one's a little hard. If it's one of those like 1, 1 and 2, 1 and 2 and 3, maybe you've narrowed down 1 and it's between. If I were you, I would have the 2 marked out, but I'd pick one of those 50% just right away in case you don't have time to go back and look. But have it starred, have it circled, so if you do have time, you can go back and look. Does that make sense? Okay. Just strategies for multiple choice. It's actually probably good for any standardized test that you have to take, but there you go. I think you guys had a question on number 7, right?
Yeah.
Okay. Number 7, graphing calculator problem. Let me grab out my graphing calculator real fast, because as we talked about yesterday, there are some skills that we might need to still be working on with our graphing calculator. The volume of a spherical, oh, look, they're so nice. They're not sure that we would remember the volume of a sphere formula. Well, that's quite nice. Is increasing at a rate of, calculus speak. How do we put this into? And it should be cubic. Nice, and it is. Uh-oh. Well, they fail miserably. Cubic inches per minute. Change that. That's a typo. Cubic inches per minute. It should not be inches. That makes no sense. Yikes. At the instant when the radius is increasing at a rate of, what am I trying to find? dr dt. Are we tracking? Such that t equals, no, such that r equals 3.20 inches. So guys, if I need dv dt, and I can plug in dv dt, I need dr dt, who am I doing to this guy? A derivative, good. So what's the derivative of this guy? Is equal to?
4 pi.
The 3 comes down and cancels. 4 pi r squared. Okay, pause. Are we all good? Sweet. Then all we got to do is plug and chug. So then when we plug in, let's see what the answer is. Because, well, the problem is right there, that inches cubed, that might be, meaning that they might have messed up the problem. So if we plug in 2 pi 3.2 squared dr dt, dv dt is 0.78. We should be able to just take our 0.78 and divide it by, now careful, if you're doing this just like this, you need to put a big old parenthesis to divide by everything. If you don't put the big old parenthesis, you're going to mess it all up. But if you put the big old parenthesis, divide by 4 and pi and 3.2 squared. Divide by 4 and pi and 3.2 squared. 0.006. Yeah, no, it's so dangerous. Back in the olden days, this was something that we had to go over time and time and time and time and time and time again. Why haven't we now? Because we have this cool alpha y equals. And so usually I have you just do the nice fraction. The problem is if you do the nice fraction, do you guys notice that sometimes it puts the answers in fractions? So then you have to go change it to decimals, which we can do, right? We can go ahead. The nice thing is, though, that you won't make this mistake. But as long as you put the whole thing in denominators, it'll be all right. Real quick, how do we do that whole decimal-y thing? Oh, -1. P.S. Have I shown you guys the shortcut? Oh, I guess we can just go back. Never mind. If you ever need to get to the beginning of an equation, you can hit second back. If you ever need to get to the end, you can hit second forward. That can save time. But anyway, we need to change this to a squared. Lo siento. There we go. Okay. Oh, never mind. It wasn't a nice fraction, so it didn't do it. But if it ever did, we could go to math, and then we would just go to decimal, not to frac, but to decimal. Okay, any other questions on multiple choice? We have 9 too? Okay. Well, it was a harder one, right? Someone tell me something you were able to put in calculus speak. Okay, what's the picture? Oh, dx dt. That's a good idea. Daredevil attempts to scale. So we have going up, right? And the camera is, we have an over, right? And then the camera's looking up? Okay, cool. So then the climber, what do we want to make him? Can we make him, what do you want to make him, y or x? ds. Okay, so we'll call him s for the skyscraper, or c for climber, whatever. The camera, we're going to call this one c for camera, I suppose? Okay, c for camera. Radians. Let's talk about the angle, right? What equation, come on, relates a right triangle, an opposite, an adjacent, and an angle? TOA! So tangent of theta is equal to s over c. You're welcome. Comic relief. So we have TOA. SOHCAHTOA. Is anything staying constant the whole time? Think, the guy's climbing, the camera's moving, but what's not changing? Where the camera is. It's not one of those cameras on the cars and they're like chasing the guy. Anyway, nope. Camera's staying stuck. So C is constant. What can I do with constants? Plug in. We could do quotient rule. We could also rewrite this. If your brain can get this, it'll save you time. We could also rewrite it as 1 over 400 times s. Wait, didn't we do this yesterday when we had dy over like 1 minus y? Didn't we rewrite that to be 1 over 1 minus y dy? We can do that with this too. And look how much easier this derivative is than this one would have been. Okay, so then coming back. What do you guys got? Secant squared theta, d theta dt equals 1/400th ds dt. Do you guys agree? Yeah. Because s is just to the first power, power rule. There we go. Derivative of tangent is secant squared. My inside is theta, so d theta dt. What can I plug in? Oh, calculus speak. Who's 16 feet per second? Good. And he's moving where? Up, which means the distance is increasing. So I'm going to make it a positive 16. Does that make sense? Sweet. Through how many radians per minute is the camera angle changing when the climber is 300 feet up the building? Oh, wait, do I even need S? I don't even need that clue. They just gave me something extra to confuse me. I need to plug this in. Pause. I know. Pause. Why is Charlotte being like, but? I don't need the 300 for S. But what? Oh, who am I finding? No. I'm not trying to find the angle. I'm trying to find d theta dt, right? Ah, well, who else am I missing? Theta. Pause. You're not missing theta. You're missing secant of theta. Yes, you're missing theta, but you're missing secant of theta too. Why am I saying that? Didn't they tell us that we're supposed to stop the climber at 300 and consider? Hey guys, what would my triangle be if I have 300 and 400? 500? Don't I just need to figure out who secant is and plug it in and square it? Do I actually need to do any sort of inverse trig? No. All I need, and this wasn't a graphing calculator problem, you couldn't have done it. All I need is the secant, and secant, choshakao, remember? Sha, hypotenuse over adjacent, or secant is the reciprocal of cosine. Reciprocal of cosine. So cosine is 400 over 500, so secant is 500 over 400. Oh my goodness, the zeros reduce. Secant is just 5/4. I took my right triangle. I plugged in the 300 that we're stopping at momentarily. I know the 400, a 3, 4, 5 triangle. Then I just said secant is hypotenuse over adjacent. Booyah, let's plug in 5/4. And now all of a sudden I can get to d theta dt is equal to 16 over 400 times the reciprocal 16 over 25. That's disgusting. I mean, we can reduce here, right? Because 4 goes in 4 times and 4 goes in 100 times. Wait, 4 goes in 1 time and 25 times.
But if you think about it again, it's like one of those problems that's like it's gonna take longer than
Most related rate multiple choices.
Yeah, but that's why there's not a lot of related rates. If you see it, you could just skip it and come back to it. But if you're like, no, I can do this, just stick it out a little bit longer. But guys, check it. Wait. Is there any way that this would be 1 over? No, the 16 can't reduce. They're odd and he's even. So it's no. Oh, look, hey, 625 must be 15 times 15. And I didn't even have to do it. I mean, maybe some of us, sorry, 25 times 25. Some of us have it memorized. There you go. Charlotte, yeah. Wait, what? No, you can't find the angle. Oh, if you can use your calculator?
No,
If you can use your calculator, you could do tangent inverse of 3 over 4.
but if you don't.
You can't. It's not unit circle. We can only do it if we have like 1 and square root of 3, if we have, well, this one they only gave us opposite and adjacent. So we could do it if it was square root of 3 over 3, 1, root 3, 0, or undefined. Otherwise we couldn't, because only the unit circle values are possible. Yeah. Okay, what else we got? Okay, we're down to the FRQs. I am totally okay, since some people are gone today anyway in both classes. I'm okay if we go over FRQ. Okay with you guys? Just so we can do a few logistics and get you guys your mock APs. Let me go ahead and... And some of you too, I'm hoping today helped in different ways. So I'm hoping that maybe you're able to do more of the FRQs than you thought. And guys, hold on, wait. Don't a lot of you still have evens that you could try? You guys know what I mean? So if you have evens that you could try, maybe practice related rates some more this weekend, because I promise it'll be on the exam somewhere. I don't know if it'll be FRQ. I don't know if it'll be multiple choice. I don't know if it'll be both. But oh, they can be so nice and so easy if you just figure out the calculus speak. If you just figure out the calculus speak as far as how to translate, and then you carefully take your derivatives using implicit differentiation, et cetera, et cetera, et cetera. This is the exam that my people on Saturday took. This is the exam that my people on Saturday took. I'm going to go ahead and zoom in on the part that you guys already know the whole 1.2 thing, right, from our spring break exam. You already know that the FRQs are 1 point each. You end up with a final composite score. On your Scantron, when you get it back, this is my Saturday one. I'll go ahead and pull up my other one also. Remember my kiddos that did the Saturday one, you're going to get the Monday one for your other full-length practice exam. My ones that got the Monday one, you're going to get the Saturday one for your full-length practice exam. I'll need to email it to you, though, sadly, because it's the ones I can't go posting online because I could lose my teaching status, or AP teacher status. So I'm pulling up the other one as well. But for those who were here on Saturday, I can do Mondays real fast because you guys do have a little bit different weighting, meaning the tests were a little bit differently, like as far as the hardness scale according to the AP graders and sample student distributions, which is how they figure it out every year. I can't, because if I put it in your class folder, anyone with the link can view, because I make it so that kids who aren't signed into their Heritage Warriors or parents can access it. So it's public, but if I email it to you, it's private and password protected. Does that make sense? As long as you don't go posting it online and then it could trace back to me, I could still lose my teacher status, so I am putting in a way my life in your hands. Okay, this is the Saturday or Monday one, this is the Saturday one. Let me just explain this real quick. When you get your Scantron back, you are going to get a score that I have calculated by taking the number of multiple choice that you got right. So please check me, the number of multiple choice you got right. You should be able to count the pink number on the front of your Scantron plus the pink number on the back of your Scantron. That's how many you got right. I should have put on your Scantron 1.2 times that number, and then how many points you got on your FRQs, and you should be able to see that on your FRQs. The BC kids were helping me total that, and it's a number out of 54. Okay? That should equal a total composite score that I put out of 108. Now, if you were to divide this, you could figure out what percentage you got right, but that's not really the point for my purposes in this exam. I took this total and I placed it in a range. Now, if you got a 70.4, there is no rounding up. So that would have been a 4. If you got a 25.3, that would be a 1. Now, if you guys notice, where are the biggest ranges? The 5 is the biggest, and the 1 is the second largest. All the others are pretty small. If we can get everyone broken out of the 1 range, I've never actually had an AP class. Everyone is broken out of the 1 because it's really hard to break out of the 1 for some. But if I can get you broken out of the 1, all of a sudden there aren't that many points. It's like 1 FRQ to get from one to the next. Literally, 1 FRQ, 9 points for most of these ranges. Maybe not all of them, but at least 1.5 FRQs. We can say 2 FRQs. Okay? But to get from one score to the next. So I've had people go from 2s to 4s, from 1s to 3s, from 1s to 4s, from 2s to 5s. I've had kids jump. This was 2 weeks ago. We hadn't finished our reviews. Once I placed you in one of these categories, this category, I split up the points and I figured out the distribution. And if you had a 70.4, you probably actually got the 100, but I still had to give you the 4. Okay? If you're in this range, it would be between an 80 and an 89. This range would be between a 70 and a 79. And then this range between a 60 and a 69. Okay? That's what the scoring looks like. On your actual AP, the FRQ portion, you will see where I have written something like a mid 3, a low 3, a mid low 3, a mid 2, a mid 1, a low 5. I don't think in AB we really had any mid to high 5s, but you will see where you are as far as the range. When you get this back, does this define you? Not in a good way or a bad way. This was just one step in the process. The corrections are not due on Monday, but I want you guys to start looking at your exams because you don't have a new review to be working on. I want you to start looking at your exams, and I want you to start correcting. Wait, on correction paper, there are literally like 108 problems. No, there's not 8 problems. There's 6 FQs and 45 multiple choice, 51 problems. But we're not going to do correction papers. But you are going to do a different colored pen on the test itself. So I want you guys to go ahead and paperclip your multiple choice questions to this test. Paperclip the whole thing together, because you need to keep the whole thing together in order to be able to do your corrections. No, it's on your exam. Did you already get yours on? Are you in a different period? I must have put you in a different period on accident. Okay, so you guys take a little time now. You can come and talk to me about your exam at any point. Pause. What am I hoping? I am hoping. Can you guys double check that no one got on stuck on theirs? I feel like ons got stuck on someone's. It was alphabetical orders. So it's, oh no, on you were in period 6. I'm good. I put her in the wrong period. Okay, guys. My hope, I want you to hear this. My hope is that as we do corrections, you're like, oh yeah, I figured this out in the area volume packet. I know how to do this one now. Oh yeah, I figured this one out in the related rates packet. I know how to do this one now. Oh, that was such a stupid mistake. I didn't know how to use my calculator on that one. Oh, I didn't even think to try. I want you to see what you can do with this now that we've finished our LTF reviews. We have another practice exam that you will get another experience, or you can use it as an experience to try to grade yourselves as far as where you are currently or where you are next week. This is where you were 2 weekends ago, right? That was a while ago. We've done a lot of work since then. So go ahead, paperclip the whole thing together. You need your multiple choice A, your multiple choice B, you need your FRQs. My people that took it on Monday, if you want to peek real quick, here's yours. My people that took it on Monday, here's yours. Meaning They thought your exam was a little bit harder because your curve was a little bit better. But they also took a different exam, and I trust the College Board people that how they grade it is with all their statistics and all their studies and all their sample groups.
Do you have?
I did it just the way that they would do it.
Do you have like Gaussian curves?
Bye, guys.
Or do you have distribution curves for our class?